From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 329, recorded live Thursday, July 19th, 2012. This episode is brought to you by Telerik, offering the best in developer tools and support. Online at telerik.com. And by Franklins.net, training developers to work smarter. And now offering GesturePak, a powerful gesture recording and recognition system for Microsoft Connect for Windows developers. Details at gesturepak.com. In this episode, Scott talks with Immo Landwerth about WinRT and Windows 8 for .NET programmers.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and today I'm talking with Immo Landwerth, who works on Windows Runtime. Thanks for chatting with me today.
Good morning. Hey, how are you?
I'm good. Good day. So let me understand this. You work on Windows Runtime, or they call it WinRT, and this is the new programming model that is kind of introduced in Windows 8. And what I wanted to talk to you about is how this fits in, because I've heard explanations of Windows Runtime before, and I don't like the explanations that I'm hearing. They're too confusing. They make it seem either like a bigger deal than it is, or a smaller deal than it is. And there's all this FUD. There's all this fear, uncertainty, and doubt. People are saying it replaces .NET, and .NET people should be afraid, and other people are saying, it destroys everything. Other people say that this is really amazing, and it's this great new thing, and I want to get a balanced understanding. So I figured I'd go kind of straight to you to talk about it. Does that sound like a plan to you?
That sounds awesome. So technically, I'm not working on the from the Windows perspective. I'm actually working on the .NET side of things. So
even better. That's great.
So basically, that should always answer the question whether .NET is dead. It's not. We are very happily working with WinRT, and I think the overall picture is pretty similar to basically everything that we did before. So if you just think of like an old school WinForms .NET 2.0 app, the thing that .NET developers are used to is P invokes, right? You would basically just call to Win32 APIs if you had to do something that wasn't part of the .NET framework. And if you think of WinRT being basically the successor of Win32, so you no longer have to P invoke, instead you can use WinRT APIs, and it's just nicer in essence. Okay. So if you call WinRT APIs from code, it looks almost exactly the same as regular .NET code. So it's just a better version of Win32 at a very, very high level.
Okay, so that's a good place to start. So I started programming many years ago in Windows before Win32, when Hello World was about 90 lines. And fast forward to today, and if you really want to exploit the hardware, for lack of a better word, if you really want to get down to it, Win32 and the Windows APIs are where it's at. I mean, that's where the power is. And every once in a while, you'll do something in .NET, if you're a .NET programmer like me, and you'll hit a wall in .NET, and then you have to go down to the Windows layer and really call something. Like just recently, I was working on this pan, tilt, zoom camera, and I wanted to do it all in .NET because that's what I know. Not really interested in doing it in C or C++. And I hit a wall immediately because there are no .NET APIs that really represent cameras on Windows. And then I was into Direct Show and COM, and I felt like I was in hell.
Yeah, and that's exactly the problem. Like if you think back in the very early days of .NET, in .NET 1.1 and 2.0, we had a whole bunch of people whose job it basically just was wrapping Win32 or COM-based APIs in a nice .NET outfit so that you can easily consume those. So I think from a .NET perspective, I would not necessarily draw the line and say Win32 or COM is where the power is. It's just a different technology to, do APIs. And from a .NET perspective, you basically prefer .NET APIs not because, they're .NET APIs, but just because they're more usable. They typically have friendlier names, and you can just new up stuff. You don't have to, poke in the registry. You don't have to do any magic stuff, basically. It just works. And basically, the problem that we had is when we wrapped the Win32 or COM-based APIs that Windows or, other Microsoft people provided is that we were basically abstracting their APIs away and wrap them in ours. So whenever they added the feature in later releases, we had to do the same work on our side. So a good example is like in Vista, they introduced all these, nice, UI features in the shell with the glass chrome and whatever. And if you use WPF, for example, you have a hard time using those because WPF, didn't have time, implementing those or, providing APIs in the .NET side for those. So basically people had to do, stuff on their own to actually use the new features. And the whole goal of WinRT is basically to stop that and to basically say, what if the APIs that are already provided by Microsoft for the native developers, for the C++ type developers, if they would already be in a shape where we no longer need to wrap them for usability reasons because they are already really, really usable. And that is basically what WinRT provides. WinRT basically provides a new technology to do APIs in Windows at the lowest level outside the CLR, right, for C and C++ developers. But if you consume them from .NET, you can directly consume them. There's no, developer on our side in your way that, wraps these APIs and gives them to you. You can just directly consume them.
That's a really interesting way to think about it, because I think that, this is just my opinion, but I think that the word runtime has and had a lot of baggage. So when I heard Windows runtime, I'm thinking that like .NET is gone away and is being replaced by this entirely new CLR thing. But when you explain it, the idea that you're taking the Windows APIs, and like you said, not necessarily the most powerful ones, but simply the ones that are the ones I want. Whether they're powerful or not doesn't matter. The fact is, I want to move my camera, and I had to drop into a very low-level world that's not comfortable. And the abstraction leaked through. I mean, it was just leaking C++ and COM throughout everything I was trying to do. And I was doing all this work to wrap, and that's such a dirty word, to go and wrap and hide complexity. So you're saying that WinRT is an API that lets you get to native stuff in Windows, do low-level, high-level, all sorts of different stuff, everything from beep to move cameras around. But when I consume them from .NET, they look like they're in .NET? They look like they're really high-level APIs?
Yep. I mean, effectively, there's probably two important things that make this look like .NET APIs. The very first thing is, if you think of COM, you always think of things like, I don't know, iCamera_2X or something.
Exactly.
Like really ugly names.
Yes.
And the other thing is you have to deal with things that are not necessarily things you want to deal with. Like, what is the format of the string? Is it a B string? Is it a zero-terminated string? Like, they have like 500 types for the same thing, more or less. And I think these are the two major things where complexity in COM kicks in if you consume it from .NET today. And in WinRT, some people might know him. His name is Christoph Solina. He wrote the framework design guidelines that we pushed basically through the whole .NET stack and made sure that when we implement APIs, we do it, in the same way. Like methods that add to collections are called always add and not sometimes prepend, sometimes append, sometimes add. And we made sure that we are consistent. And when the WinRT guys came along and designed their APIs, they explicitly asked for Christoph's expertise and said, can you help us design our APIs in such a way that they look, familiar to you guys? And so just by naming stuff in a little bit easier way, I think lots of the, COM ugliness already disappears. And the other big thing is they simplify their type system a lot by basically saying there's only a single type for a string. You no longer have to convert one string to the other just, for the fun of it. And I think this is like probably the two biggest things that they did like on the surface. Like when you drill deeper, of course, WinRT, and this is where the runtime part kicks in. Runtime, if you think of runtime and you think of the CLR, that's the wrong thing. The CLR is not a runtime; it's more like a VM, a virtual machine, because it provides things like IL. It provides things like a garbage collector, like a JIT compiler, that sort of thing. Whereas the classic, very old C runtime is just a set of APIs, and it's called a runtime because it's, a set of utility methods or functions that you can call that do stuff for you, like memory allocation, memory deallocation. And if you think of modern apps, like apps today, talking to the camera is almost as basic as, allocating memory. So it makes sense that the operating system provides those for you. And, they just went with the term runtime because that's what, even native developers use all the time. But they don't mean like a full-blown CLR execution environment with, all the things that we would call managed. They are not part of WinRT.
That's where I think things get a little confusing, because the word runtime, like we said, is so overloaded. But you're saying that it's not like a complete runtime in that it's not someone else's perspective on what the CLR should look like.
Correct. There's no GC, for example. Like the way the whole WinRT system works is effectively the same way COM works today. You just add ref into release, so it's ref counted, and so there's no need for a garbage collector. When you stop using stuff, the ref count goes to 0 and stuff just disappears. And so it's basically just a set of APIs that you call. And then on top of that, there's a whole bunch of things that are supposed to make your life easier. So, for example, in C++, they did some language extensions so that you don't have to do ref counting yourself, so that the language can do it for you. So it almost looks like you don't have to actually deallocate memory, but, in C++, it's part of the language, so it makes it easier. And on the C# side, we obviously have NVBs as well. The CLR has basically has all the mechanisms to deal with COM already. So we basically just leveraged that and updated it to work very nicely with WinRT. So from both sides, whether you look from the C++ side or from the C# side, it looks as being part of your everyday language activities, if you think that way. And the same goes for JavaScript as well. And this is what the Windows guys call language projection. So they basically try to work with all the languages and technologies together to make sure that WinRT is not necessarily the lowest common denominator, but a really great system, and it can be adopted to work well in all the worlds, be it JavaScript, C# or C++.
Okay, so that was my next question. I want to understand this word projections. So
yeah,
I'm a .NET programmer, so I care not only about .NET but primarily about .NET, because that's where I feel like I can get the work done. So I can call WinRT APIs, and they'll feel like .NET APIs. It doesn't. I'm not going to feel like I'm in a new world when I go doing this. It should feel familiar and comfortable. Is that correct?
Yes, that's the goal.
Okay, so the part that's interesting to me is that then this is really not about .NET. It's about making the Windows APIs callable from anything, and that's what this projection term is?
Yes, that's what projection basically means.
So
it's a very fancy term, but it's not very complicated.
Is a projection like metadata? Is it a piece of metadata that gives a language enough information to call? Like, could I write a projection? I don't know if I'm using the words right, but what if I wanted to call WinRT from Ruby? What would I have to write? Would I be writing a projection, or would I be calling into a projection?
No, you would write your own adapter. So basically, if you think from the WinRT side, they basically have defined what they call the ABI level, which is the application binary interface. So they talk about like how are things encoded, like how does metadata be represented, like how do I discover what methods are available. And in fact, the underlying metadata format that WinRT is using is more or less the same that .NET is using. So they're also using assemblies, but they don't contain code, right? They just use the metadata part of the .NET assemblies, if you will, to encode what APIs are available to you.
Right.
And then there are certain Windows APIs that you have to call in order to really instantiate objects and to get them. But this is all part of the WinRT spec. And if you're a language implementer, let's say Ruby, for example, you can just use that, and then you have to do some work on your side. So, for example, you have to make a decision how the strings that Ruby has are mapping to the strings that that WinRT has. So basically, in the .NET side of things, we can just directly basically pass them along, because it just happens to be that the underlying format is the same on both sides. So there's no string copying involved. But if you decide to encode strings completely differently, then probably you want to have some smarts in your language or in your compiler to convert those strings automatically for the users, because otherwise it will be painful again. And that is what we mean by projections. Language has to make a decision how their constructs, like in strings and so on, fly well with the other side, which is the low level WinRT ABI level. Okay,
so I think this is where it's funny. There's several levels of confusion here. So the first, we talked about the word runtime. I think that provided confusion, because it is in fact a runtime, but that word freaks out .NET people who feel like we own all runtimes. You know what I mean?
Yeah.
So that's kind of like the first step. But then the next one is really interesting, is that when we, the .NET people, think about .NET, we think of it as kind of an all or nothing thing. And you just said that the metadata format used by Windows Runtime to talk about these APIs is .NET itself, but not in the, that's not the right word. The format that it's encoded in is that the standard that we've released, the ECMA 335 metadata format, the format that .NET uses is the same. And that kind of muddies the waters and makes it blurry between what's .NET and what's not. But really, you guys just didn't need to invent a new format, so you picked one that already existed.
Correct. They could have just chosen whatever format, right? If you go very hard, they could even have used XML for that, but it's just not the most efficient way to store that information. But yeah, it's just that other guys already did the work, so why reinvent the wheel?
Mm-hmm. Okay. Are there other pieces of .NET that are used, or is the metadata the primary thing?
I think metadata is probably the primary thing, and then, of course, naming conventions or that sort of thing is also reused, if you think of that way. But I think at the underlying thing, I can't really think of many other things. Of course, if you think of API design, depart just the naming conventions. For example, WinRT also has a low-level type system, if you will. So they also have to provide collections, for example, because if they provide APIs that return many objects, you want to have a unified set of APIs that represent those collection types. And so they have, for example, IIterable, which is basically the WinRT equivalent of what the .NET developers know as IEnumerable. And so they're not low-level types, but they're common enough that the .NET side decided to have a projection. So if you call a WinRT API that takes an IIterable, from the .NET side, it seems like it takes an IEnumerable, and you can just pass on your IEnumerable. You don't have to write any code for that. It just happens automatically. And this is also part of the projection layer. And the original designs, I think there were many different flavors of IEterable. If you think of the C++ STL, the standard template library, they have 500 ways to do iterations over collections. So they modeled the same thing on the C++ on the WinRT side. But in the design review meetings, we basically said, well, it's very hard for us to do the projection. It's a very common thing. Many language features on our side depend on that, and can we simplify these things? So I think this overall, let's set on one thing and let's not make too many things. I think this general attitude of .NET being more productive because we have fewer concepts to deal with, I think is also now part of the WinRT design philosophy. And so it's more like a reuse, and it's a thinking that went over. I don't think there's many other pieces in technology-wise that are reused.
So my initial reaction to this idea of IIterable and IEnumerable, my gut reaction is that someone is looking in a thesaurus trying to find another word that means the same thing, and IIterable and IEnumerable are effectively identical.
Correct.
And then I'm thinking, why isn't the Windows runtime using more .NET idioms? But then I'm kind of remembering that .NET is not the only customer of WinRT. Presumably,
correct,
it has to look like Windows for C++ and JavaScript as well. I presume that I could for each over an IIterable, and as
correct.
a .NET program that would feel comfortable. Can I do the same thing in JavaScript using .each and different JavaScript type idioms?
I'm not too familiar with JavaScript, but yeah, I would think so.
Okay, so what I'm trying to get to is the idea that's the point, is that I think I'm understanding the point now, that you've got these Windows APIs. They are native APIs. They're built into Windows, and you have to find a balance between being really awesome on Windows, but not making the programmer who's using their own language of choice feel uncomfortable. So a JavaScript person writing Windows code shouldn't feel like, oh, this is gross, this feels Windowsy. They should feel like, oh, this is JavaScript, I know JavaScript. And the .NET programmer shouldn't have to be learning new stuff. They're going to go, oh, for each, great, I can for each, just like I'm familiar with. So it's a balance between feeling idiomatic and comfortable in the language and still not watering down the power of Windows. Is that correct?
That is pretty much the best thing I've heard so far. Yeah, I mean, I think that if you look at the very first design sessions or architecture sessions for WinRT that were on build, for example, they had these slides in them that confused many people because C# was on the one hand side on desktop apps it was listed on top of the .NET side, and then on the Metro side it was listed on top of WinRT. So people thought, if you're using C# in WinRT, you actually compile down to native, and then magically you run on this Windows runtime. But that's not the case. It's just APIs. And yes, the goal of the WinRT system is to enable Windows to provide APIs, and they're immediately consumable from the programming language. And the immediate part is the important thing, because in the past, every language always has provided wrappers around operating system stuff. But then the problem is, when the operating system guys evolve over time, languages couldn't expose it as quickly. And this is why sometimes people said, if you really want to use the API, you really have to go to C++ because it's the only way you can actually consume it. And then if you have .NET customers, yes, you have to write a wrapper and adapter in between. And all of these things go away because all of these projections are now done. So whenever someone in Windows decides to produce a new API, it's immediately in all three languages, I should say stacks, because it's the JavaScript stack, it's the CLR stack, and then it's the native stack. They're all available in all of in all of these stacks immediately. So the operating system can evolve over time, and languages and developers can immediately start consuming those as they come along. And I think that's really good news for the .NET developers as well.
Okay, so does that mean that if I write a WinRT API, it'll be awesome on all three programming interfaces?
That is the goal. Surely you have to do some work to make it awesome in all of these things. So, for example, if you decide to expose something in WinRT, you have to think about having, if you implement it in let's say, .NET, you have to think that your consumers are probably not necessarily in .NET, right? They might be in .NET, but they also might be in JavaScript or in C++. So you have to make sure that when you author a WinRT component, you have to adhere to the WinRT rules. And they're slightly different from the .NET rules for authoring DLLs, but they are not completely different. So you still have the concept of classes and methods and so on and so forth. But there are certain types, for example, that you shouldn't expose. So, for example, if you write an async method in .NET, you would return a task. Right. But on the WinRT side, they don't have tasks. They have a different way to represent asynchronous operations. So you have to call a method that converts them. So why didn't we do a language projection for that? Well, because it was too complicated, and we couldn't cover all the cases, so we decided to make it more obvious for the developers so that they can make the corner case decisions themselves, and to say, here are APIs that convert between the WinRT representation of async APIs and task objects. And then you have to author those and basically convert between them. But there are not many. It always sounds very complicated when people start talking about these things. But I mean, all in all, if you just start writing a WinRT component, it is you just go to VS, you create a new class library, you change the output type to WinMD, which stands for Windows Metadata, instead of a regular DLL. And then you start coding, and then you get compiler errors for stuff that you're not supposed to do, and they will automatically guide you in the right direction. So there shouldn't be much to worry about.
So the task async was the next thing, because we've got a lot of really cool stuff around async in .NET, and we've also got a lot of really cool stuff around parallelism, with the task parallel library. So these are becoming idioms that .NET programmers are going to expect. Are there a lot of idioms that don't have support in WinRT that one should watch for? And are those idioms that you'll kind of continue to expand on?
I think except for the nice thing with the WinRT async object that they return, I think it's called iasync info when I remember correctly, and they have derived object for them as well, is that from a .NET perspective, if you start consuming those, you won't see a task of, let's say, int or whatever the API returns. You would see whatever the WinRT type is, but you can immediately use the C# language extensions await and async to basically directly await these operations. And this just works because the C# compiler itself didn't really bake the knowledge of task in for await. They basically said, if you provide the right methods on the other guy, then you can await this effectively. So it's the same as with link. It was the same way, right? If you implement a certain pattern in APIs, you could use link queries on top of those. So from a C# perspective, if you just consume APIs, there shouldn't be much to worry about. It will just work as you would expect it naturally. If you author WinRT components themselves, then yes, you have to be aware of that. You know, on the WinRT side, you don't have to deal with, you can't use tasks. But if you basically split the CAM into two people, one just consuming WinRT APIs, the other one producing them, you find that the producing camp is much smaller anyway. So typically you have component vendors that will, let's say, build new components, let's say a new daytime picker for XAML, for example. And yes, they probably author them in WinMD, but I don't think this is the mainstream scenario. I think the mainstream scenario is consuming APIs. Okay.
So when you're consuming APIs, I know that in the idea of profiles is becoming more common. In .NET, you have your references that appear over on the right-hand side in the Solution Explorer. And those are then collected more and more. We're seeing in .NET collections of APIs. So like there's the portable library stuff where you can say, here are the APIs and here are the references that I want to share. And even we on the website have been thinking about maybe collapsing those references into some kind of a web profile so that would make it easier and there wouldn't be so many DLLs like visible. When you are targeting a Metro style application in .NET, there's this Metro style profile, just like as if I were writing a portable library to run on an Xbox. I can use specific things and other ones are unavailable to me. Help me understand when can a .NET person call Windows runtime APIs? Can I write a console app and call WinRT methods?
No, you can't. And the reason being that we didn't expose those APIs if you target Metro. And this is also not necessarily news for developers, right? If you're remembering the Silverlight days when we produced Silverlight, we didn't expose all of .NET. We only exposed some subset of the .NET APIs because Silverlight was a separate version of .NET altogether. And Metro is similar in the sense that the number of APIs that we give to you is severely restricted. And the reason being that we want to make sure that you basically see the right APIs that are applicable to Metro style apps and not all of the history of .NET, which is, 10 years worth of, APIs. And not all of them make sense. Some of them have actually been obsoleted or deprecated. Some of them are actually quite dangerous if you use them, not necessarily correctly, and it's very easy to use them incorrectly. And so we decided to subset the set of APIs significantly for Metro. And I think all in all, we are down to maybe 35% or whatever of the full framework that we give to you in Metro. And we think this is the right set of APIs. Like, we don't think we hid anything from you because we didn't like you to use it. It's just that we think having WinForms and WPF, for example, doesn't make sense because if you're at a Metro app, for example, you have to use the WinRT XAML stack anyway, so it doesn't make sense to expose them to you. And so the challenge now for the .NET developers is obviously that typically you don't just write apps, right? You also write libraries that you can reuse across different apps. And so this is where Portable Class Library kicks in. So if you basically target different platforms, Portable Class Library makes sure that you get the right set of APIs that is effectively in the intersection of the platforms. However, moving forward, we think this is not necessarily something we want to do much anymore. Because if you think of Silverlight in .NET, for example, the subset was almost arbitrary, right? If you look at String, for example, String might have 50 members on .NET and only 25 on Silverlight because, just the way it was designed. Now, in the new world, what we have done in this release, we basically said we break down our assemblies in more fine-grained, smaller components. So, for example, MS Colab, as it is today, is a big pile of stuff that is almost unrelated. Like, there's remoting in it, there's reflection in it, there's strings in them, there's collection types in them. So if you create a new platform, it's very likely that you will subset MS Colab one way or the other. And so in the new world, we basically created smaller assemblies. So, for example, our equivalent of MS Colab is now called System Runtime, but this is really, really, really small. It only contains basically the primitive types and a few interfaces, and that's it. Even collections is no longer part of that. Collections is a separate assembly. And so the idea is if you decide what assemblies you actually want to depend on, then your binary that you're compiling against those things is binary compatible with all future platforms, that support the dependencies that you have. But you can be sure if you depend on System Runtime version 1, every platform that supports System Runtime version 1, your binary is compatible with that. So Portable Class Library, instead of being a separate class library, will be just the default. You just create class libraries, you pick your dependencies, And depending on the dependencies, you are portable to a platform or you're not portable to that platform. But it's really up to you. It's no longer the problem that, oh, shoot, if I created a .NET class library, I cannot just copy that one to Silverlight because it's a different platform.
When I hear that people are limiting APIs, it makes me feel limited. Like like you're saying, you found the right subset, but kind of experience usually means that that's great, except for that one function that I really have to call that you removed. How do you get around that?
So right now there's no way around it, but we made sure that we didn't just arbitrarily, throw a dice. So basically what we did when we decided what APIs we expose, we did two things. First of all, for certain areas, let's say collections, for example, we decided to stick with existing platforms. So for example, the idea was if you already shipped a platform with that set of APIs, chances are that this is the right subset for the set of people because, we didn't just decide to remove certain methods, for example. The other thing that we did is we analyzed the phone app store for API usages. So we basically created a list of APIs and then said, how many times are those called per app? So we know which APIs are called frequently and which APIs are not called frequently. And we made sure that if we remove APIs that are used frequently, we have to have really good reasons to remove those APIs. So, for example, it's a dangerous API, or it's not applicable to Metro because it's WinForms, for example. And so we hope that by construction we avoided the trap of just removing someone's favorite APIs. Of course, it's a V1 if you think of it. It's a new product, so chances are there are APIs missing, but there's no way for you around it because if you submit your app to the App Store itself actually validates that you only use the APIs that you're supposed to using. And the reason being is that if you think of security problems or whatever else, the Windows App Store guys really want to make sure that if I as a consumer download an app, I have confidence that the app doesn't own my computer or starts doing crazy stuff. So they really want to make sure that the apps have high quality. And one of the ways to ensure it is to make sure that the right APIs are available and not like dangerous APIs are exposed.
Okay. All right. So it's not arbitrary. I mean, there's analysis going on here and what we're calling. And because I would hate to start getting really excited about Metro and then discover that one method that I need is not going to be available.
No, and I think one other thing to be aware of is that as we go along now in the future and we create new platforms that we create will be based on the assemblies that we give you in Metro. So in Metro, if you don't have to deal with assemblies because if you create a Metro app, the assembly list that you see is collapsed to basically, I think, just two things. One of them says Windows runtime, and the other one says .NET for Metro style apps or something along those lines.
Right. Those profiles.
We just give you basically, all of the .NET assemblies that are exposed to Metro. But if you actually look at the binary that you're producing, you have dependencies on stuff like system collections, system runtime, that sort of thing. And if you actually go to the reference assemblies folder where we show you all the assemblies, this is basically the set of assemblies that we would give to you in future versions of whatever other runtime we invent, right? And so we are really confident that this is the right set of APIs, and we probably, add more contracts along the way. So, for example, right now there is no no assembly for console, because guess what? A Metro console doesn't make sense. But if we would create like a new version of the runtime that would specifically target console apps, for example, chances are there is a system.console, and this is a new assembly probably because it doesn't make sense to keep it in the other assemblies.
Okay, cool. All right, well, I feel like I get it now. I was a little bit concerned as a .NET guy that there was some evil going on here, or there was some tension, but it seems better. I feel less concerned. I did not want to learn an entirely different runtime that was like a parallel universe. You know what I mean? Yep.
And we hope we didn't create that either.
All right, very cool. Well, thanks, Immo, for talking to me today.
Sure.
This has been another episode of Hansel Minutes. We'll see you again next week.